Okay, so we're going to look at example 1.9, find the normal to the curve y equals ln, and then we've got a fraction of x plus 1 over 3x minus 1 at the point where x equals 2. We're going to go about this the same way we normally do, so we'll derive the function. So we'll go y is equal to, now here, what I actually can do is I can rewrite this as this fraction using log laws of subtraction. Okay, so when I have a fraction like this, I can subtract the numerator and the denominator. So here I can derive this rather nicely. So dy dx would equal to the derivative of x plus 1, which is 1, over the original function with ln. Here it would be x plus 1. Then I'm going to subtract, okay, deriving 3x minus 4 gives 3 over 3x minus 4. Okay, brilliant. Now, I need to let this equal to 0, so I might actually make a common denominator here. So I'll multiply the left fraction by 3x minus 4 and 3x minus 4. Okay, and then I'll get this common denominator of x plus 1, 3x minus 4, because I'm also going to multiply the 3 by the x plus 1 over x plus 1. Sorry, it should be minus 3x plus 1. So let's simplify this a little further. So expanding the top over there, I'll get minus 3x minus 3. So I'm actually going to get negative 7 because the 3x's will cancel over x plus 1, 3x minus 4. Okay, now this will be the gradient. So when x equals to 2, now remember when I'm looking for perpendicular gradients, I have the gradient of the tangent multiplied the gradient of the perpendicular would be negative 1. Okay, so here I'm going to sub 2 in, and then I'm going to put that answer into this solution here to solve for the perpendicular gradient, or the gradient of the normal. So m of the tangent here would be negative 7 over 2 plus 1, and then I'll have 3 times 2 minus 4. So I'll have negative 7 over 3 times 2, so negative 7 on 6. I'll just fix that up, negative 7 on 6. Now, putting this m of the tangent, the gradient of the tangent, in here, and then I'm going to solve for the gradient of the normal. So gradient of the normal would be negative 1 over the gradient of the tangent, so it'd be negative 1 over negative 7 on 6. Okay, I could rewrite that, the numerator of negative 1, I can rewrite that as negative 1 on 1. I'm going to flip and multiply this fraction, and I'll get the gradient of the normal being 6 on 7. So now I've got the gradient of the normal, I've got my x point. Now I should find the actual original y coordinate at x equals 2. So when x equals 2, y would equal to ln 2 plus 1 over 2 times 3, which is 6, minus 2 of 2. So that would be ln 3 on 2. Now using another way to write this, okay, I could rewrite that as ln 3 minus ln 2. So that's my y coordinate. So I'm going to put this into my 1-point gradient formula of y minus y1 is equal to m bracket x minus x1. So here I have y minus, and then I've got this here of ln3 minus ln2 equals to my gradient of 6 on 7, x minus 2. Little bit of algebra here, so I might multiply everything by 7. I'm going to write this in general form, so I'm going to have 6x minus 7y plus 7 ln 3 negative 7 ln 2 minus 12 equal to 0. So there we go. We have our equation of the normal at x equals 2.